1.3, the first part that I'm going to quiz you on, the part that you may or may not have learned, I hope you have, but it's going to be very important to do things in this way. So let's look at an equation that's got just one fraction in it. Now you might be inclined to start by going -7 on both sides, subtracting 7 from both sides. But I want to encourage you, anytime there's a fraction in an equation, do this the same way. We're going to multiply both sides of the equation by whatever the least common denominator of all the fractions is in the problem. In this case, there's only one fraction, so it's 4. But notice I took the extra time to rewrite the problem so that I can see where I started out, because this gets messy. And then I took the time to show that I'm going to distribute. I'm going to multiply that 4 times everything. And now I'm going to do my distribution, right? I'm going to take that extra step and show that I'm multiplying everything by 4. On the right, I already did the multiplication. I'm going to cross cancel to simplify. If you like to do that, great. If not, don't, but you're going to want to do that by the end of the year. Lots of fractions. So then we've got an equation with no fractions. If you don't get to a fairly simple equation with no fractions, something's wrong. You picked the wrong LCD. Now I just subtract 20 from both sides. Subtract 28 from both sides, divide by 3, and we're done. And we can write it like that. That's a simplified improper fraction, or we can do the division and get a decimal or a fraction. It's important. Don't forget that you have to multiply both sides. Everything's going to need to be multiplied. We can't change the value of just one thing in an equation. If we're going to change something using multiplication, we have to do it to both sides. And take the time, do that extra step, show the distribution to all the parts. It's really easy to forget that poor little 7 in there. So you'll make less mistakes if you take the time to write that little extra step. And, don't be in that big of a hurry. So let's look at one that has a couple fractions. This one happens to have 2 fractions. Doesn't happen to be the thing with the variable, but that's okay. So you could, of course, just multiply or just subtract 2/3 from 4/5, but why would you want to? So the LCD here between 3 and 5 is going to be 15. 15 is the smallest number that both 3 and 5 go into. So I'm going to rewrite the equation, show the distribution, actually do the distribution, show that 15 being multiplied by all the parts. I'm going to go ahead and simplify over here. Again, cross cancel to simplify. So now I have a nice little 2-step equation that has no fractions. Again, if you don't get to that point, something went wrong. You picked the wrong LCD, you did the wrong math. That's a really good check to make sure you're on the right track. So now I'm going to subtract 10 from both sides. I'm going to get 15x equals 2. Divide both sides by 15. And we get 2/15. I'm not going to bother with a decimal. That's a nice enough fraction. Again, in a perfect world I'd go back and check, but the fraction ones I tend not to. So let's do one more involved problem. This one we're going to have 3 fractions. So we've got 3/5 x minus 2 equals x over 6. Remember, there's an invisible 1 in front of that. It's really the same thing as 1/6 x plus 7/10. So what's our LCD going to be? What's the smallest thing 6 and 5 and 10 go into? I always take the biggest number and just count up by that number. So they don't all go into 10. They don't all go into 20. They do all go into 30. So we're going to use 30. And since this is a big one, I'm going to skip that first step of showing that I'm going to distribute, I'm just going to jump right to the distribution. And you can do that, because every time you're going to be distributing to all the parts. So you're just going to multiply every term in the equation by the LCD. We can do some simplifying. So we get 18x, multiplying that 6 times 3x, minus 60. We can do some more simplifying. 6 goes into both of those, 10 goes into both of those. So then we have 5 times x gives us 5x, 3 times 7 gives us 21. We've got options. I happen to choose the 5x to subtract first. Could have added 60, could have subtracted 18x, could have subtracted 21. All of those would have been fine. Since I might be doing it differently than you, I'm going to show all the steps. I'm going to add the 60 to both sides. Now I only have one option, divide by 13, and so I get 81 over 13. Now, again, that can't be simplified. 13 is a prime number, so 13 doesn't go into 81, so I know I can't simplify that fraction, but let's actually do the division. Remember, it's saying 81 divided by 13, so 81 goes on the inside, 13 goes on the outside. Good double check is 81 is bigger. It's an improper fraction, so you better get a whole number when you start your division. And so I know 13 times 4 is 52. That's a good one to know. 52 weeks in a year, 52 cards in a deck. And so what's after 52 would be 65. That'd be 5 times 13. I think you can go one more. So I'm going to go with 6. Yep, that's 78. Subtract there. We get 3. And so since I want to write this as a fraction, I'm not going to add a decimal. I'm not going to keep going. To write it as a mixed number, 6 and 3 over 13. That's it.